Morning everyone, let's wait for 1-2 minutes until everyone joins. Okay, good morning everyone again. So let's start our today's session. We will continue. We'll start with the remaining part of our presentation about inheritance. As you remember, yesterday we were discussing some different things, and we finished with the operator instance of and of course we also were discussing already a lot about the casting of reference types. Let me check the Discord so I can follow. Yeah. Yes. Yesterday we were already talking about casting of reference types, and I think I already mentioned these two things, like upcasting and downcasting. I didn't explain you a lot about these two terms, so maybe let me show you a bit. So yeah, let me show these three pictures from yesterday, three paintings from yesterday session. So as we can see, if we go from the variable, in this case, let's maybe let's paint. Let's have a new paint so it's maybe more clear for you. If we have the variable with the type, with the reference type, with the type of class, mention that this is the variable with the type of class, which has the instance. We actually at the moment we don't really think about the instance. Just we know that there is an instance inside this variable with the class, and if we want to pass this instance, which is located inside this variable, to another variable, which also has is typed as the class, with the reference to the class, which is the superclass of this variable. So I mean, superclass of the class to which this variable is typed to. So in this case, that's also a variable, and in this case we go from the bigger one to a smaller one, from detailed to general, and in this case it's called again, as it's said here, we call it super. If we go down, if we cast to the superclass, here it's called upcasting. So we do the upcasting here, And in an opposite way, if we go for, we don't really care about the instance at the moment. Just we have instance inside this variable. And, if we go again to from in this case that's the superclass, that's the variable which is typed as the superclass, and this is typed as the subclass. So in this case it's called downcasting, right? Hope it's clear. Maybe again let's go to our top design. If we go up, right? If we go up, it's called upcasting. If we go down, it's called downcasting. Hope it's simple. And again, when we use downcasting and upcasting, we are talking about the variables, not about the object instances which are located inside this variable. It's just about the variables. And yes, upcasting can be done automatically. Again, what was said yesterday. And because object from subclass is an object of superclass, it can be checked by compiler. Yes, that's true. Again, that's the most simple case. Yeah, yesterday we talked about this case. So it always works. It always works, and from the code point of view. Thank you, Marita. And to be honest, I'm really bad painter, and I have one of the worst handwritings you can imagine. But I'm trying to improve something. Okay. Yeah. Thank you, Marita, for your comment. So. Yes, and as it said, it can be done automatically. I think I had this example somewhere here, or not. Where did I have it? In here. Yeah, practice makes perfect. That's true. Yeah, and yes, here we had the example with with bird and fish and animal. So here is, if we go this way, maybe let's write again. Just no, maybe not. Let me just comment this section. Then just to not confuse. That's not initialize. So yes, we have just variable which is typed as bird. Then we have the variable which is typed as animal, and basically now just let's create. So yeah, this is not the casting. Again, yeah, this is the case when there's no casting, because we have animal here on the left side and we have animal on the right side. But if we want to pass the, again, that this is the animal. This variable is typed as animal, and if we want to pass bird to animal, it happens again automatically, and yeah, it happens automatically. So this is called upcasting. Upcasting, because we pass from subclass to superclass. It's easy. It happens automatically. If we want to go other way, again we need to use, again, first of all, compiler do not understand downcasting, because the yes, compiler do not understand the downcasting automatically, because again, as as we had the example yesterday, it can raise the exception class cast exception, which means that we cannot cast subclass to cast superclass to subclass. Again, because all the subclasses are more detailed than the superclasses, and that's why we need to use cast operator, but in this case we take the responsibility that we do, for example, we do the check, or if we already know that this is the instance of the bird, we can cast it this way. Yes, and basically the idea of the casting is if we, again, imagine you have, let's paint. Imagine you have a huge framework with the codes. You have class somewhere here. Let's use rectangles. Imagine you have class somewhere here. Then you have class which calls a different class, which calls a different class, and so on and so on. Just let's imagine you have a huge hierarchy with lots of classes, and yeah, go here, then go here, then go somewhere here. So it's not the hierarchy. That's just one. For example, one method is called from another method. Then just imagine you have so huge chain, so huge framework. When you have another, for example, class where the attribute is located, then you, for example, you pass the attribute somewhere to this class. Then you want to take it again from here. So imagine you have maybe some huge chain, some huge framework, and imagine you have the object created somewhere here. Somewhere here, it has kind of maybe it has the generic types. It has some type, it has some type with reference to the class which may be subclass, or yes, which is subclass or not subclass, or just any class. And maybe let's think that it is the subclass or the class A. For example, we have class A, and here we create the instance which is the instance of class B, which extends class A, right? Extends class A, and for example, we also can have another class here. In theory, again, we can have so. And imagine that we pass this object. We can pass it to here or to here, and here is the logic which needs to process, which is processing this object. Yeah, we can have two different classes, and for example, we have another class here, and imagine there can be created, for example, another class somewhere here, or passed, or something else. And in this case, we, for example, can have two options here. We can have something that's maybe more clear. Let's have another class which extends class A, for example. Class A. Then, for example, from this case, we pass the instance of class B, and here from this place we pass the instance of class C. Both of them are the subclasses of class A, and here we want to do some stuff with these two classes, or for one of these two classes, because we cannot call the same method twice at the same time. So, and here we want to just do something with these two, but we don't know what is the type of the object which is passed to this method. In this case, we want to create some more general logic which allows us to process this these objects, one of these objects. And for this case, we can use class A. Again, we can do the upcasting, which will work every time, but in this case we cannot use all the properties. Again, as you remember, class B and class C, these two classes are more detailed than the class A. And in this case, if we cast B or C to A, for example, B or C to A, we cannot use all the features of classes B and C. But again, if we and yeah, again, imagine that this, for example, yeah, in this case, this is the method, right? We imagine we are in the method. We are in the method with importing parameter which has the type A again, but we want to use the features from B or C. Basically, that's our need. And it's how to proceed if we have the parameter which is passed as A, but we know that it can be B or it can be C, right? And in this case, we need to use the downcasting. Downcasting to downcast it to the type of B or the type of C to use all the features from B or C. And yeah, that's maybe just a simple example. Imagine you have a huge chain, like if it's the web development, there are so many. Again, in web development, there can be created kind of generic. As from my experience, we have in the system I'm working with, there is generic code, which again has so many views, windows. Yeah, imagine the web development, views, windows with different classes, and what we can do, we can extend these classes. We can extend these classes, and this is the example how we can extend the views or the windows and the logic there. And for this purpose, we usually need to use upcasting and downcasting, and even maybe more downcasting, because we have the generic logic which is kind of the buffer, and if we want to pass from one place to another, we usually use more general classes. I mean, we use the variables which are typed as the classes which are more general than the actual classes there. And the idea is that if we want to pass one object to another through the huge chain, for example, again, if we have a huge chain, like one class, another class, and so on and so on, then in this case, the downcasting can be very, very useful. But don't worry if you can't really get it now, because yes, I think the best way to understand it is to have the practical example. I hope we will have it. We'll have it very soon. But yeah, again, we're in stepping, so yeah, if you, yeah, thank you, Ian. So yeah, it's a kind of example. And if you are in the place where you don't know which instance of which class this is, so in this case you can use downcasting to use all the features of these two objects. Another point is that there can be abstract classes, but abstract classes and interfaces. We'll talk about them a bit later, but that's also the point of upcasting and downcasting. Right. Yeah, just maybe let's maybe create a short example in here. So if we even here, let's create a method process animal. Then we have the importing parameter, for example, which is tagged as animal. And imagine one thing. Let's maybe comment this out. But what we can do, we can imagine if we define the constructor of the class animal as the protected one, so we cannot, so we will not be able to create the instance of this class directly. We will need to use the subclasses, right? So if we have constructor defined protected, we cannot create the instance of this class outside the class. But we can do it with the class bird and class fish, because both of them has public constructors. And this game, but we have the variable with the type animal, but we just know that we cannot create the instance of animal directly, only the instance of bird or the fish. And so in this case but we want to deal with this object in some way, and we know that there are two options here. So maybe let's use try catch again. Just have this here. Let's use try catch here. Again, we have the method. With the importing parameter, and what we can do here. And we don't know if that's animal or fish. So first of all, we can fish equal. And again, yeah, this is the downcasting, and you can see that it's not possible to do it without the bracket, without the operator in brackets, casting operator in brackets. And we try to, let's for example just to understand this correctly, let's print out that we've been here, right? This is not fish. I'm not the fish thing this way. So an exception is called then, and let's try again. We can have another catch. Let's use this case, then let's try again. Bird. No, in this case we don't need, because we know that should work. That should work. we want to use this this variable as the bird, the fish, or the animal, or the fish or the bird. See, and the bird. And imagine that we call this method somewhere from here, somewhere from here. And let's create maybe a private static void instance here. Display this animal. Then we can pass the instance of, for example, have the instance of animal, which actually is bird. Let's run it. Yeah. And just don't need this one. And again, we can see here get animal, that get animal here. We will return fish. So let's return bird. Let's return bird. As you can see, during the compilation, we don't see all these errors, only after the execution of the code. So yes, as you can see here, we try to do the first upcasting. It then jumps to catch statement. It means that exception is called class cast exception. Right? Then we try to cast to bird, and then you can see the casting is done correctly with no exceptions. And this is the case, for example, if we have, just imagine, we don't really know what's happening there, we just have the method, and we can see that the importing parameter of the method is animal. Yes, we need it because in case we have some kind of very generic, maybe not generic, but very general code with lots of general lots of general parameters used for the methods, and like in this case we have the general parameter here passed, and if we want to process this parameter as, if we know that can be the fish or the bird, then we can actually proceed with them using casting operators. Right. So yes, let's move on. I hope it's good now. But yeah, that's basically the main usage. If we have kind of very general framework, then there are, to make it easier to transport, to not create different methods for the objects to transport the objects, to use them, we can use upcasting or downcasting. I hope we will have some more examples about it, so don't worry. And, yes, and downcasting can rise casting exception. We already faced them because it can be done incorrectly, and it can be checked only on runtime. That's the disadvantage you need to deal with. And yeah, again, as I recommended yesterday, use instance of check before downcasting to escape all these errors, all these exceptions. And then we have method overloading. That's the idea when the same method, the method with the same name, the same access modifier, the same returning parameter or void, and with with the same name has different importing parameters with a different type. There can be some tricky case about it, but again, that's just a small reminder for you, so you can refresh knowledge about it. Overloading example. Class just then imagine we have void just let it be simple method just for you to understand. Then we have one. Then we can pass as you can see, we cannot declare the same method twice because it doesn't make sense. So we can overload it. Yeah, we can overload it this way. Then we can overload it this way, and so on and so on. We can print something out. Nothing is passed. Can print that integer is passed. Then we have string is passed. Let's create an instance of the class then yes, we can call the method by passing the integer, for example. Then we can pass the string. Some more. And yeah, based on the parameter provided, it calls the first method here, then the second method once we provide the integer as the importing parameter, and if we provide the string, that shows that the word is passed and this method is called. And yeah, this is the overloading, just when the same method has different importing parameters. And if we have something like this, we cannot do it because even that it has kind of returning parameters, it shows that this is the duplicated method. So it considers this method also as duplicate. So everything is based on the parameters, and if we change the access modifier, it will also show that this is the duplicate. So everything depends on the parameters which can be passed to this method. And yes, this is what overloading is called. So again, where you need it, if we have kind of different implementations to be done for different attributes. In this case, you're welcome to use overloading, and maybe I think we had such example during the first session, one of the first sessions, but it's about the sum. But integer, that's return. So then again, if we have two numbers, a, b, then we can return a plus b. And if we have kind of three numbers, then we can do it this way, but we can also do it this way. Maybe that would be even more clear if we extend. Again, this also can be used as the extending. When we're talking about the overriding methods, we consider two cases. Again, the first case is when we want to extend the method, and in this case we call the method from the not this case, but in case we want to extend the method, we just call the implementation of the superclass first. We had here, I think, we call the implementation of superclass first, then we just do some extended stuff. And the different usage, another usage is that if we just override the implementation totally with absolutely different logic, which is not related to the superclass, to the method from the superclass. And in this case, it can also be done. The same way. So first of all, if we want to extend, like in this case, we just have the sum of two variables, but we want to have the sum of three variables. Want to use the sum of three variables, then we can first do the sum of two variables, and then we want to extend this a bit by adding another variable. And this is an option. Only option is to extend the methods with the same name. You can also extend methods with different name, but yeah, that's up to you, your wishes, and up to your requirements. And yeah, another point is that it's possible that you just create your own implementation here with a plus b, which is not related to the method with the same name. Right, that's the usage. Yeah, again, arguments should be different enough. In case of float and double, it can create confusion. We'll take a look on such examples hopefully today. So the constructor overloading, the same with the constructors, the same as for the methods. For constructors, it's absolutely the same, that we can have the different signature of the constructors, same way as for the methods. And yeah, they should be unique. Then we have kind of example of constructors, of the overloading of constructor. Then we have class employee, for example, with some attributes, constant attribute, Then some other attributes, and we have different constructors here. So again, as for the example we just seen about the sums, which is based on the parameters provided. Same is here. If we have less or more or any kind of different parameters, then based on these parameters passed to the method, like not the method, to the constructor. Maybe let's show this example here. I think was that we already have the same class. No? Oh no. It's fine. Let's remove all these messy characters. Right, it's already defined. Maybe let's change it a bit. Complete to finish. So what we can see here, there are three constructors. There are three constructors for the object with the type of this class. What we can do, we can also call one constructor from another constructor. For example, if we pass, let's create a public static void main string arms. And then if we want to create the instance of employee, so here we call the constructor, right? And here we have different options to pass. As you can see, we have now the standard constructor. So in this case, we'll pass the name, just the string. This will call this constructor, which then calls the constructor with two importing parameters, which is as we can see this one. Then this one calls the constructor with three parameters, which is this one, right? And that's maybe a bit confusing, but this is quite straight example of the approach when the overloading is used as the way to extend the code in the method, in this case in the constructor, and to deal with it. And again, basically the idea is that all the employees have name, salary, birth, but for example not for all of them we can provide, and not in all cases we want and we need to provide all the parameters to to this employee, and some parameters can be used by default. So in this case we can see that we cannot create an employee without the name, right? Because name is defined in all the constructors, but we have option to provide the salary. It's kind of this way. We have option to provide the salary, then this one, this method will be called. Then we have another option to provide date of birth. Option to provide date of birth. That would be a bit tricky. New date. Here we have date of birth. Yeah, this is the class we defined. Maybe let's use these as the public ones. So, oh no, we don't want to use them as the public ones. Why? Because we have some restrictions here. Then maybe that would be kind of the best way to show why we need to do the encapsulation. So then we have public method set month of int a. Yeah, that's now we go back to encapsulation a bit. Public void. And again, what we know that month can be 1, 2, 3, 5, 6, 7, 8, or 9, 10, 11, and 12. And then we can check if a is greater than 0, and 8 is less than 12, 9 and 13 in our case. Then we can set up the day, the month. Alright. So this is the way why we need encapsulation. And just notice that else print that system out print that incorrectly. And yeah, since we have one statement, the only statement here, we don't really need the brackets, and here as well. Right. So the same is to let's use this getter. Get month. Let's public int. Sorry. Get month, and let's return this month. Right. Yeah, the same about the year. Set year. I think we have no restrictions for year. Oh no, maybe let's strict that no one can be born before 2021. Right, this here, same about here, and get here. This is example again why we need to encapsulate the variables. Why we need all these getters and setters, because we don't want to set day. Also, we can check if the day is kind of if the day does not exceed the number of days in each month, number of possible days in each month. It's kind of the 30 of February. Of course, that's incorrect. So it can also be restricted this way. We'll not do it. And yeah, we have and a is less than 32. This and yeah, this day equals day. Same here. So yeah, this is why we need. This is why we need the encapsulation here. I don't think that's a simple way to explain why doing it. Let's go back to our employee. Have new date, and so we know that the instance is created. Then we can set day. That will be before, for example. And yeah, that will be a bit tricky because we cannot call all the methods this way. So in this case, let's remove it from here and declare the date here. Date. Then let's set them this way. Set month be December. And date set here. Right, then we pass the date here. In this case, we can see that this method will be called, or we have the name and date of birth. And yeah, this is the object in this case as well. So yes, and the last option here is to pass all the parameters. In this case, we cannot do it. We cannot do it this way. We cannot do it this way because we must follow the sequence. We must follow the sequence. As you can see, on the first place there's name, that's correct, but on the second place there's the salary, not the date. In this case, we need to write that down this way, and everything is correct. So yeah, I hope you got the idea that how the overloading works. In the constructor case, it's also very important, based on the parameters passed to constructor, and yeah, we can have some default values like salary in this case, which can be set as the base salary. Right, let's have 15 minutes breaks, maybe a bit longer breaks. So let's meet at 10 past 10. Yes, welcome back. One small remark for those who wrote the questions to me. I think we'll spend the last hour of our today's session from 1 p.m. to 2 p.m. to answer your questions today. Yes, if you have any questions about the home task for this week, or any other questions, you're welcome to ask them, but we'll discuss during the last hour of our today's session. Right, let's move on. Yeah, about the constructor, the overloading of constructors. If we use operator this as usual, it means that this is the it calls the constructor, right? And if this passed the parameters, it will call the constructor. Let's move on. Yeah, one thing: constructors are not inherited, but the constructors, as we had tested yesterday, the constructors call the constructors of the superclass, even if we don't ask them to do it, right? Yeah. Then, yeah, of course, we also talked about the method super. That it refers to constructor and superclass. Yes, as we had the example yesterday. In this one, not this one. Which one did we have? Not from here, but yeah, the idea is that just if we call the super, we call the constructor from the superclass, and it needs to be called as the first statement, so we cannot call it somewhere in the middle or at the end of the method of the not of the method of the constructor of the subclass. It method constructor of the superclass must be called at very beginning of the constructor in the subclass. Also, again, we can pass any parameters we want. It's the same way as for all the constructors and all the methods. And if parent class do not have constructor without arguments implemented, then implicit referring to such constructor will cause error. Right, that's true as well. We already had such examples. And again, if it goes up to the hierarchy, if we have the constructor of subclass, then constructor of the superclass will be called automatically, and the constructor of the superclass will be called as well. I think maybe, let me search for this example. I think we had, yeah, here we did. We have three classes, and yeah, if constructor from this class is called, then the constructor from this class will be called as well, and then the constructor from this class will be called as well. And we have three constructors, and all of them will be called. Right, let's move on. Yeah, this also one is so same example we had about the employee. Then we have Then we have the manager, and maybe let's show this example here, because that would be, yeah, that was here somewhere. As I remember, we had manager, and basically we can just use the same one we just used here, right? Have the class employee as we already created it today, and imagine we have the class manager, let's pass it here. Yes. Let's modify it a bit, so just maybe let's do it this way. Let's replace, then let's format it. And, yeah, and yeah, it's already defined, so let's maybe change it to, and so yeah, what's the idea is? The idea is that again we have manager, which is also employee, right? And then for the constructor of manager, we obviously need to call the superclass to construct all these things we want to construct. And note one thing, that that manager, the class manager 2, which extends the class employee 2, do not have these attributes available. I mean, name, birth, and birth salary are not available. And the constant base salary, all of them are not available for the class manager 2 because they are private, right? We have private, all of them are private. That's why we need to access them using the, in this case we can access them using the constructor from the superclass, right? And we call them constructor from the superclass and pass the parameters which will be passed to these attributes. Moment. These attributes. Yes. And same here. If we override the constructors, if we overload the constructors, then we can also can call the corresponding constructor from the superclass. And of course we can add some additional parameters here. Alright, let's move on. That's about, and yeah, one more thing, will fail because there's no constructor of superclass without arguments department. With arguments department. Yeah, with this case. So we cannot add we cannot create the constructors with our own signature with different signature in superclass. No, we can create, but we can use them as the additional parameters in case there are no parameters, these parameters from superclass passed, as in this case we haven't passed the name, haven't passed the salary or something else. In this case it will raise a compilation error, but if we, for example, change the name here, it what's the problem here? Yeah, it's it won't work as well because we don't invoke the constructor from the superclass. So in this case we cannot even use this way. No, we can, but actually, yeah, in this case we need to call the constructor from the superclass this way, but not this way, right? That's the same about the depth. And why it is so? Because I think it makes sense. It does not really understand which parameter is this. It cannot pass the parameters automatically, right? I think we had such example yesterday, because there's the superclass and all the constructors of the superclass have their importing parameters. But of course, if we don't call anything here, it doesn't make sense, because the constructor from the superclass need to have some parameters to be imported, and of course that would be quite complicated for the compiler, for the code, to understand how to pass the parameter and basically which parameter is here. That's why in this case we need to use such call for the superclass, for the constructor of the superclass, and it will work. And of course, if we pass depth, that would be incorrect, because we don't have such constructor in the superclass. We need to have name. So in this case, again, here we defined in the employee class that we must provide the name to basically to construct the employee. Otherwise it can be done, because all the employees must have the name. And same as here, we cannot create the instance of manager if we don't provide the name. And that's why here's the error. I think it makes sense. Let's move on. And again, need for encapsulation. We already had this example today when we were talking about the date. So if we provide the date, we must restrict the values to be entered to the date, because there are 12 months, 31 days during the year. Yeah, and we cannot pass any other values there. Right? Makes sense. One moment. Right. And yeah, that's why we need encapsulation. And for the dates, it's even more important than for other classes. And yes, when composing complex object structure, important question appears: how to access this internal structure, how to access and how to modify. Let's show the example for the date. Yeah, for example here. We have the birth date, But what we know about the type of the birth date, this is the class date and basically one thing about the getter. Imagine that we want to get the birth date of birth of employee. But we don't want this this date to be returned as the object, because for example we want to have just a simple like month, day, month and year, for example. Yeah, we want to have such output. We don't need to have such outputs with kind of strange classes and so on. We just want to have the basic output, and in this case, of course, we can return the string this um, birth date, get day. Sorry, then let's pause. Then this get month dot plus this birthday. Sorry, birthday get year. Right. For example, we want to have such output to be provided in the getter method. And in this case, we also need the encapsulation. We don't actually want to access kind of very technical attributes. We just want to get the date. And if we just want to get them using the string, we can use the getter method. So it's easier for us to actually get the date we want to get. Right. That's why we can have the need to we can have the need to have getter methods. And about the setters, in the same way, if we want to again restrict the creation for the getter methods, for the setter methods, we create setter methods, and we can restrict the modification of the global attributes from the class. Right. Then, yeah, this is also the kind of example. If we don't have the encapsulation, we can provide some very strange values for the date, and it doesn't make sense if we do it this way. There's no validation and nothing good here. Right. And yes, if we have the methods, then we can actually check the values provided, and it's easy to do it. Yeah, we already have this example just right now. Then there are two things I already mentioned. Yeah, the first one is inheritance. We just faced it a lot. Then there are the superclasses, and there are subclasses which extend the superclasses. And you should know the difference between the inheritance and the composition. So maybe let's go through the examples we already had. Yes, as we can see here, there's just there are three examples: inheritance versus composition. In the case of Greenwich machine, As the baseline, we use refreshment machine with two functionalities: to serve orange juice, for example, right, and to serve Coke. Then the inheritance is that again we have two same the same functionalities, and if we add a new new one, a new functionality here. This is the inheritance. We inherit all the previous functionalities and we add something new. This is called inheritance. And if we have the composition, it means that we have a new. Let's call this as the class, or just let's call this as class. We have class, and all the previous functionality is located inside this class. So in theory, that would look like. Let's go back to example of manager and employee and manager. So we have, as you remember, we have the class employee and manager, and this is the way of inheritance. We just extended the class employee too, right? Then we created the class manager too. But this is the inheritance, right? But if we want to create a composition, let's just create manager 3. That's not a good naming. Just in fact, if you have some practical assignments, especially if that's kind of real assignments, please think about the namings. In this case, I'm just creating the examples to show you something, but if you have real examples, not real examples, but real development, please think about the naming and the reason why this class is created, for example, and give the corresponding name to it. But in this case, it's just to show you. So let's move on. Imagine that we created the class manager, and let's don't use the inheritance. Let's use the composition. What can we do in this case? In this case, we can have the attribute, right? And the attribute employee private employee 2 employee equals, let's for example just use this way, employee. Then again, that's what we can do here. We can create the constructor. Let's just, maybe I will not cover all these examples. I mean, all these constructors with overloading. Just create one constructor for all the attributes. Again, let's add the department. And here we can create the instance of employee equals new employee 2, and then let's just pass all the parameters here. And in this case, we have the employee inside, and this is called composition. Of course, in this case, composition is not the best approach. Why? Because we know that manager is employee, and this how it we just want to extend the functionality of employee. So in this case, the better approach to extend it. But of course, if we do it this way, it means that this is the composition, right? So the composition is that we place one class inside another class, and that would be the composition. Otherwise, if we use the extend, that's the inheritance. And yeah, from practical point of view, that may be a bit confusing to distinguish them in practice, in practical work. So yes, for example, if you have like again web development, you have the view, you have the window, for example. Yes, like for example, if there's a pop-up somewhere here, like this one. So this is the pop-up. Let's consider this as different window. So yeah, this is the window, and what's inside, that's view. But in this case, please don't think that, like imagine if we have the class view. So the view is what's located inside the window, right inside this window. Please don't consider the window as the subclass of consider the view as the subclass of window, because this is not really correct. So we can see that the view is located inside the window. It's not kind of subclass subclass of window, because in theory this view can be used in different windows in the same way. So in this case, there's no sense that we consider this view as the subclass of this window, and that's the difference. That's what is called composition. And please don't mix them up. This is not the same thing, right? Again, composition is where you use if you use different classes for one class, and the inheritance is when you just extend the functionality of the superclass to the subclass. Yeah, then let's talk about so-called diamond problem. So in other programming languages like in C++, there's such option possible like multiple inheritance. Multiple inheritance, like you can see in this case, like we have the base class, animal, then we have two subclasses, which is the case we already discussed, shark and human. But then let's imagine we have another class, amphibia, which is shark and human, right? Yeah, this is basically, in this case, is called multiple inheritance, when one class has two different superclasses. In theory, and from my point of view, that's kind of a good idea to have such thing in the programming language to be available in some cases, especially in cases when there is a bad design of the classes of the framework implemented. Like I faced it in my experience, that there is already a very bad solution created where kind of same code is written in lots of different places. So in this case, I thought about if that would be really great if there is multiple inheritance, then I can create my own code in one class, then add it in addition to the previous classes which were extended. Yes, to just add them to all the classes, but unfortunately there was no such option available of multiple inheritance in programming languages I was working with. But yeah, that's the good point, that you can add some multiple functionality to one class. The problem is that the main problem and the reason why multiple inheritance is not allowed in Java. Yes, there's no option for multiple inheritance in Java. Is that, for example, if you have kind of same attributes or the same methods in class shark and class human, right? In this case, and you extend either public or protected methods or attributes, like you extend these two classes in one class, and in theory this class does not know which method to use, right? Actually, this class will have two same methods with the same signature, and of course that's the problem. That's the problem. And yes, for example, if there's method move, method for shark, and method move for human, then you call the method move for amphibia, and amphibia does not know if he expected to walk or to swim. That's the problem of multiple inheritance, and this is why it is not used in Java. In place of multiple inheritance, you can use the composition. That's what we were just discussing. So if you have the class animal, the base class, then you have the class shark, have the class human, both of them extend class animal, and you have the class amphibia, and you have two parameters here. First one is again shark, the second one is human, and you move, then you just check if you are on the ground, that you can do the move. You do the move what humans do, and if you are in the water, then you can swim. Basically, the one the shark does. That's the idea, but again, yeah, without encapsulation, it could be unsafe. Because again, in theory, for example, you have the class amphibian, you have it somewhere used. Again, amphibia has two parameters, and for example, you know that you want to use amphibia as the fish. Then you create the class, the instance of the class amphibia. You pass, you initialize the class, the attribute, the global attribute of the class, attribute shark, for example, and you don't initialize the attribute human. And in this case, since the global attribute is not initialized, you cannot use it, because this is the class, and to use the instance of the classes, you must initialize them. You must create the object. That's the idea. And that's why, again, encapsulation is the best way to use it. Maybe again, let's I think we already have the class. We have the class animal. Maybe let's use the same class here. Right. We have the class animal. We already have the class fish. And let's create the class amphibia. Class amphibia. And imagine we have We have two attributes. The first one is again fish, shark. As you can see, we don't initialize it. Let's again use them. First of all, let's try to use them as the public one, and let's see what's the problem. Public. I think we don't have human here. Okay, let's create human as well. Class human. And let's have let's maybe extends animal. Then let's create the method move for animal. Public void move. And again, we don't. Let's create this method as protected one, for example. Protected. And again, we can implement it to be implemented in the subclasses, for example. And yes, one more thing I haven't shown you about the overridden methods is that we can make them public void move. We can make them like more visible than the one from the superclass. As you can see, we have class animal. Again, we have class animal. Animal has protected, right? Protected void move. We don't implement there. We don't implement there anything. It is protected here, but we can increase the visibility, the access to public one. We cannot decrease it to the private one, right? But we can increase it to public one. Yes, here we can print out that I'm walking. For example, that's about human. And yes, and let's create the attribute human. Maybe for the fish, let's also override the method. So since this is extended from class animal, we can override the method from there. Swimming. Yeah, that's kind of we can actually call the same method from here. Alright, so yeah. And now let's implement the movement. Again, we cannot override because we don't have the superclass here. So we just can create the method. Of course, we can add the media. This shark move if media calls round, and this human move again. Right, what's the problem here? The problem here is that first of all, as we can already see here, none of these. Oh no, maybe let's just show you in our main method here. out this code, we don't need it anymore. So let's create the instance of Amphibia. We have nothing to provide to constructor. And here, human, right, and let's ask Amphibia to move. Oh yeah, we need to provide, yeah, in this case we need to provide the media example. So this is the human one to go on the ground. So imagine that we run and everything is correctly here, but in case, for example, let's add water. Let's imagine we mistyped or there are some confusions here, and the problem is that there's an exception, null pointer exception. Why? Because that's the problem. That's the problem which can happen if the encapsulation is not used, like in this case, because we access the parameter directly. And what's the problem? We have no validation on if we can actually use the some functionality or not. Because in this case we just provide that we are in the water and we want to move in the water, but in this case we got the exception. And that's one of the problems because we don't use the encapsulation here. Let's change it to private one. Let's change them to the private. So now we can have proper initialization of the variables. Like let's have public again, public void initialize, then here we can initialize, and this shark equals new shark, right? Then this human equals new human. Again, not new shark, but new fish and new human. So now we have the compiler error here because we cannot access the human. But what we can do, we can initialize it. We can initialize it so we don't have the direct access to the variables. And if we run it here, we'll see there are no errors. If we are in the water, we are swimming. If we are on the ground, we are walking. That's the idea. And this is the case where we need to use the encapsulation to prevent all these errors. And yeah, that's the way how we can actually have kind of multiple inheritance in Java. So if we have we can actually have multiple attributes, not the multiple superclasses. And yes, this is the way how it can be done. The problem is again in the design. That's again what I said about the example I had. If we want to if we actually want to use the multiple inheritance. As the inheritance, I mean we have the methods which comes from one or another class. We cannot do it using the composition. So if we have kind of method which we want to inherit from one class or from another class, we cannot do it with the encapsulation. With the encapsulation, we need to do some more steps. Like in this case, we need to create a new method. We can't use this method. We need to create another method. We need to create kind of, so in this case we create the importing parameters, then we add some logic there, and we call the method from these two classes from inside this method move, which again we have even more steps. We have more steps here to be done. Again, new method, then the logic inside the method, then the initialization of these two variables. So we have, in this case, for example, if we had just the inheritance, then what we have the inheritance, we just need to do nothing. We have the method which is inherited, it's already there, and we don't need to do some code in addition. Here we need to again create the global attribute. First we need to create a global attribute, then we again need to create the method, then we need to add some logic inside the method, and then call the method we want to call. So in this case, the composition requires more steps, more logic to be created than just a simple inheritance. And that's why I prefer inheritance over the composition in some cases, because inheritance is more simple and more easier to create and more easier to maintain it after that. But in this case, if we have no other option, then we need, like in Java, if we want to implement kind of multiple inheritance, then we need to use the composition, and that's the only way we can do it in Java. Right, then there's package and import keywords. If we write the package name, we write it on top of the class. Then it shows us the package the class is located in. And if we have the import, it imports us the classes from other packages. Like in this case, if we add the star, it means that it will import all the classes from the corresponding package. Right. Yes, that's just an example about vehicle. So if we have the list which comes from the class list, then after that we can use it inside the logic after we do the import. Hope it makes sense. Then the package keyword again. So yeah, first of all we need to write the package, then the name of the package. Then if we use dot, then after that we can call the sub package and so on. And the packages should be defined in the beginning of the code, right? As usually defined only once. If package is not defined, class is implicitly put in default package. That's also kind of construction in Java. The default package, well, not really talk about it now, but yeah, there's default package in which if we don't actually write, if we don't provide the package at the beginning of the code, it will put in default package. pretty straightforward. And of course, and yeah, this is not recommended to put classes in default package, because in theory that can create some mess there. If there are so many different classes in the default package, it doesn't really make sense, because there's so many different, and package structure is defined from left to right, again delimited with dots. So if we go again from general to more detailed, let's call it this way. So, in general refers to folder structure and file system, again this way. I think it's pretty straightforward. We will not talk about the packages a lot now, so let's move on with the import keyword. So yeah, as I said again, in the same way as for the packages, we start with package name, then we go to the sub package, and then we finish with the class name. Again, we'll have some examples later about the import, but yeah, I think it's pretty straightforward. We just point out to the classes which are located outside the package we are currently in, to be used in our code. And if we use a star, it means that we import all the classes from the corresponding package. Right, I think it makes sense. Here are some examples, like Java utility list. So this is the class which will be imported. Also, I think you already noticed, if we, for example, we have the class person, it's on the same package, but we can import this as well. Here, like import. Here we can even use the same package. Here we don't really need to use it, but we don't really need to import the classes from the same package. So in theory, you can also see that the person, yeah. Of course, the class will be visible here, and if we delete it, will be visible same way, because we are in the same package. Public classes from the same package will be available. But yeah, that's also okay if you want to use kind of different the class from different package. For example, we have class account. It will show the error because it doesn't see this class. Then we need to use the import. The package object-oriented programming. Then we use the import of account, and we can see that the dependency is solved, because we do the import. We just imported the class from this package. Same way, if we want to use kind of different class, maybe square. Again, there's the problem, it doesn't see it. But if we put the star here, it will import all these classes, and all these classes will be available here. Alright, okay, let's have 15 minutes break. We'll meet at 11:20. Okay, let's move on. Let's move on. So yes, as we were talking about the packages we can import, and so hope it yeah, hope it makes sense that we can, using the import, we can actually import the classes from other packages. And yes, again, the import statement should be before the class definition. Instructs compiler where to find particular class from given place. And yes, import keyword is not necessary to use class from the same package. This is what I mentioned. And you cannot import class from default package if current class is in other package. As well, yes, then we can have unique class composition. So if packages and classes are used, both of them are used to create a structure of composed objects, right? And the packages are used to create the class name globally unique. Therefore, packages are used similarly as universal resource identifiers. So in this case, yes, you need to understand that class names should be unique within the package. And let's imagine sorry, if we, yes, here you can see that we have class display here in the package object-oriented programming has some stuff inside. We have the class display, which is here. So there are no conflicts since they're located in different packages. But let's, for example, try to import something as the package, and for display it's not possible because it has the same name as the class from here. Yes, you can see that it conflicts with the type defined in the same file. So be careful here. That can make some problems with the naming. Alright, let's move on. And the last thing to discuss here is dropper classes. That's kind of the same as the primitive data types, with the difference that these classes are actually the objects. So let's create the example. One moment. Let's create the example for wrapper classes. So the wrapper classes are defined kind of similar way as the primitive data types. I mean, the variables with the defined with the types of wrapper classes are defined kind of similar ways as the classes as the variables with the primitive data types, like integer, as you can see, it's not written as int as we usually do. It's written in, it's defined as def. Okay, so for example, if we do info int, then this one is defined as primitive data type integer, and this one is the integer as the class. And yes, what's the difference? First of all, about the assignments. About the assignments, we have well equals 5, for example, and we can see that it's not possible to assign it. It's not possible to assign it this way, because this is the object. This is the object. That's why we need to create this way. And yeah, we cannot do it. Just a moment. One moment. And so what's the problem here? Integer. I think. Once. One moment. I think. We need to. But there's still the problem. Still the problem here. Oh, okay, yeah, it's constructor. Okay, the constructor is deprecated. Oh, okay, yeah, that's fine, because we have. Yes, yeah, that's the problem. We have the different version of Java, and yeah, the constructor is deprecated from version 9, so this one is not correct. Just please use this syntax, and here we can see the problem is that we cannot pass the static content. That's kind of a strange thing. For wrapper class, we can provide the value during the initialization, but we cannot provide it after that. But after that, and yes, maybe that's that can be a bit tricky. I think I have some issues with the wrapper classes here because of the Java version, I think. Yes, maybe let's skip it because we have different Java version. Yes, maybe we'll talk about it later, but yeah, the problem is that so it will not work for more modern versions. But basically, we actually don't really need the proper class, but on the other hand we have the class integer. Which actually has lots of static methods. So all these methods are static one. I think we already faced them. So for the class integer, we can see there are lots of different methods. We can count the bits, we can compare to integers, we can compare to unsigned integers, decode, then check max min, number of leading zeros, and so on and so on. So many different methods you can use for string. That's why there is no actual need to use them as the proper classes, but this way. But what you can do, you can, not sure if we want to, but okay, we can maybe talk about, so this is how the class is implemented. So it some static values inside, so lots of static methods and so on and so on. But what we can actually do is we can create the list. Maybe let's create the, for example, array list. Then we can pass the template type. We can actually pass the integer. My numbers, for example, new array list with the type integer, and we cannot. We cannot do it using just a simple integer. Just a simple integer. Yeah, and the advantage of array list is that we can use it as the list. So for example, we have my numbers. Let's use this. Here, let's use a static prime. Static. Use my numbers. Is there still a problem with the streaming? Oh, yeah, it's fine. It's fine. So I think there can be some. I thought there could be some issues with the streaming, but okay, seems it's fine. Seems it's fine. So let's move on. So let's go to my numbers. Then we can. So yeah, in this case, this is the list. I think I'll talk about the lists later. But yeah, just for your information, we can use the integer as the template type for the lists. Here we can basically use this as the list. For example, we can have some numbers there, my numbers, and like 8. Then what else we can do here? Number, we can clear, we can check, so remove something, get size, convert them, and so on and so on. So many different options for the lists available. yeah, again, integer. So in this case, it should, if we declare them as just a simple value, it will act in the same way as all the integer do. With the one exception, that this is not the primitive data type. This is the object, but okay, yeah. Here we can. I'm not sure why we had some errors. You can, yeah. Please forget what I said. Even in this Java version, you can. So yeah, we have the object now. I'm not sure why I had some issues. Oh yeah, I got why. It's my fault. Just forget what you heard before about the integer. We can use them as the objects. So I thought we have some issues with Java version, but yeah, that's everything is fine. Yeah, the problem was that we are in static method now. And so yeah, so if you use integer, not int, this is the object type, this is the class, and you just have the same integer type, but this is the object, so you have different methods there, like convert to string, for example, um, and just to get the value, initial value. Actually, yeah, so many different methods here you can use comparing to the primitive data type. Int 7, for example, to call from the just primitive data type. But in case you have integer, basically you can deal the same way. System out one, then if you have two different integers, so you can sum them. Yes, you have actually the same way as for the integers. What you can do, again, you can call in some methods here. You can convert to string. Yes, if you have string, well, string, for example, you can convert to string. It will work. And basically, if you want to, for example, if you need to work with just a primitive data type, then, and imagine you want to pass the value to the string. Of course, you need to convert from integer to string. You can't use casting, because you can cast the primitive data type to the object type. You also can, yes, and you cannot call the method. The one option to use it, you can use the static. You can use the static method from the class integer, and it will work fine. So yeah, basically this is kind of similar approach. If you want to deal with the primitive data type, you go to the class integer, you call the static method to string, then you receive the string from this method. If you have the variable defined as the integer with a capital letter first place,
then you can use it as the object and return string by calling the method. Right, so this is about the wrapper class for integer, and the same is about all the other types like double and character. So I think it's pretty straightforward. So this is not the primitive date type, this is the object. This is the object. Right, I hope this is pretty clear for you. And now we can finish this presentation, and let's move on with some practical stuff. Maybe one more thing about inheritance I haven't mentioned yet is that if you have the class employee, if you have employee, then we have, for example, the method, and we add the keyword final to the method, to the public to the method which is public or protected. Then it means that we cannot override it anymore in the subclass. Right? It will be available. You will be able to call the method from the superclass. In this case, that's class employee, but you cannot override it because it was defined as final. And here you can see the explanation. Cannot override the final method from employee because this is the final one. Right? If you want to finalize the override, overriding of the method, you are welcome to use final keyword. So let's move on with the practical assignments. Here. So we have activity 5, and I'm not sure why there are no tasks here. Let me check. Check one thing. Check why there are no. Oh yeah, I think we'll need to create new classes. Yeah. Maybe let's move on with what is written in Adobe, exercise 5. Then we need maybe let's split the screen. I hope you will. No, I think that would be much more confusing. So, if you can, please open this Java exercise 05. I will open it on my other screen. So yeah, as we can see, there are 2 classes need to be created. Let's just follow all the steps to be done here. No, not all the steps, but I mean just the introduction steps, and you'll be able to finish these tasks at home, as your homework. So as it's written, create class water road. Let's do it. Water road, and it said that we want to have the superclass road from the package. Maybe let's first of all let's create the class and then it is said that the superclass needs to be imported from the activity 04, right? And let's do it. GTM put class road here, and let's extend the class road. Right, so if we don't have this import here, it will show us the error because it is located in a different package, so we cannot see it. But if we do the import, it's absolutely fine. We are able to use it. So the next step is select constructors from superclass inherited abstract method. Oh yeah, that's if we actually in our case we do the steps in the code in the same way. Maybe let's delete this class. Just you can do it. Actually, you can do it here. Water road package, right? That's fine. Then we can actually browse the superclass. So in this case, as you can see, by default it puts object as the superclass. As you know, all the classes are inherited from object, but we can switch it to a different one. So we can press on browse, then search for the class, and we can already see that it's from activity 04. Then it is said that select constructors from superclass. Let's do it. And inherited abstract methods. It's already ticked. And press finish. So yeah, as we can see, we already did it before, but it actually inherits the constructors from the superclass. There are two constructors. The first one is the default one with no code inside. It means that it will call the constructor from the superclass automatically. I don't really remember if there is a constructor with no parameters inside this class, but inside class road, but it doesn't really matter for us at the moment. So let's move on. Yeah, we can do it without the wizard as well. Then yeah, select source, override implement methods, and select to string. As you know, this is the method which returns the class as the string, and in most usual cases it is just inherited from object class and not and it may have some incorrect results, but yes, and we need to override which returns string in form water road from this get from plus dash some underscores here tool, this command, this get tool, plus yeah, counters. Right, this is what we had to do with class. I'm not sure if we'll pass the unit test this way. Yes, yeah, because we have not done all other steps. It's just the first step, which needs to be done here. For the other, but okay, we can actually we can create one more step. I mean, the fifth step from this exercise. Let's create a new class again. Class ship, which should be the subclass of transport. Again, we browse it, then we type transport. Again, it's from the package activity04. Then yeah. Then we need to protect it. Protected byte number of sales. Then we need to create the constructor. And let it be public string ID. Okay, since this is taken for the superclass, we will not reuse it. So let's sales and it's not set. What should we do here? Yeah, it said we just create a constructor. Okay, let's maybe call this from superclass by passing ID, but yes. Okay, let's move on. Maybe just this. Okay, but no, I think we can do it. Okay, then maybe let's use it first of all. Let's use default values. Then just we'll move on with what it's requested. So yeah, then we need to override the method move. Do it twice. Override the method move and return string inform. ID plus ship is sailing on plus get row a string. We don't even, yeah, just string plus with wheels with x. Okay, number of wheels. Wheels. Oh yeah, that's here. Why I put a number of? Oh yeah, number of cells. Yeah, just sorry, my fault. I just was working on the fifth one. Right. You know that fuel is not used when ship is moving because it's used. Yeah, okay. For sailing instead, and return. And return. Yeah, that's maybe a bit tricky text. Let's get so we need to use the maybe need to write it this way. If it's not the water road, yeah, if this instance of, yeah, let's maybe use this not instance of this, but not, yeah, sorry, not this road, yeah, road instance of water road. If it's not, then to return string cannot sail on a road to string. Right. Yes. Maybe let's have our last break today, and I will just clarify some unclear requirements from this exercise. So let's meet at 12. Okay, welcome back. So yes, regarding the activity number 5, and there may be some unclear things mentioned in the description of the exercise, but maybe, yeah, let's move again. So starting from point 4, the idea is to create a class, what we already done. Then we generated all the methods needed to be generated here. So here one more thing is that we can replace class water road by using this get class, and again we can get simple name. So it will return us the name of the class. So just to not hard code it, we can get the name of the class this way, right? And yes, that's what about it. And yes, in case, for example, if we want to use the subclass, that this will provide a different result. And for the ship class, yes, this may be a bit crazy way, but we need to provide zeros here, and yeah, maybe let's define the number of sales to sales here. Right, then for the method move, yeah, that was a bit trickier. That we need to no, that's pretty fine for this. For the string, that we actually need to get the type, right? Because that was from the transport class. So first of all, we need to get the type. It will return us the ID and the ship. Then just add the sailing. Then we need, yeah, just notice that this is the same as if we return it to string. And so if we return it this way to string, it will call the methods to string automatically. It will convert it to string automatically. Then with sales, number of sales as well. So yes, no, so this way with number of sales, and then turn sales, right? And yeah, this is for the class ship. I'm not sure if we can pass the unit test without other classes. Yeah, we cannot pass the unit test once all the classes until all the classes are created. So, and that would be our new home task for Wednesday. Not just maybe for Friday with all the extra activities. So yeah, maybe I'll write it in the chat now. Simple task for next Friday is to finish activity 5 plus the extra exercises from extra 05. Right, yeah, again, if you have any questions about it, please ask me, and
Now maybe so we have 45 minutes per day. After that I will give you 1 hour to ask me the questions about the home tasks which need to be finished for today. I mean this week. Yeah, until the end of today. There's activity 03 and activity 04. Activity 04 with the extra exercises. If you have any questions, you will have time to ask today. But now we have 45 minutes, and I would like to maybe give you some examples. For inheritance. So just summarize what we gone through before. Again, let's create a new class. Class then, for example, display this class teacher, for example, and we don't need a constructor here. So let's have a class teacher. And let's designation. Yeah, for teacher it should be teacher by default. Then let's assume that every teacher has college name. Beginner's book. And it's just kind of example, not just college. Let's maybe chemistry college. College of Chemistry, no, Science College. Science College. Science College, for example. And there's the void should do. Does what does the teacher do? Again, for example, teacher teaches. And let's assume that we want to extend the class to class, for example, what will be math teacher. Which extends, of course, the class teacher. And of course, then let's create one more class to just not math teacher, but teacher who has the main subject, like sub teacher, which extends. Let's use the protected. This one. So since this one won't be changed, we can use it as a private one. And the college also won't be. Maybe let's just not use it. Use protected one. Protected. Then imagine that teacher can have main subject.
main subject, a string of course, yeah. And by default we assume that there is no default value for teacher, but if we have math teacher, we can also have the constructor. Constructor, and here we can add mathematics as the main area. Teacher is working. So yeah, this is also kind of the way we can use the subclass teacher. We can use the superclass teacher. Imagine it has some attributes with no default value provided. Then we can do it in the subclass. So I think that's pretty clear. It's pretty clear here. So yes. So let's move on. Let's move on. So it's, of course, we can create another class with different subject, like with chemistry teacher, for example, which will also extend the class teacher, maybe chemistry teacher. Just note again that it will call the constructor from the superclass automatically. Sorry. And main subject chemistry. Right, then again, let's move on. I think that's pretty clear in this case. Okay, let's maybe take a bit more complicated case. Yeah, that's from yesterday. We had some virtual methods. And a topic about virtual methods. So okay, let's talk about, not talk, but let's have some examples. Yeah, again, imagine. Maybe just let's use the same one. So again, we have instance of teacher. Now we have the class teacher. In essence, maybe we can do it the same this way. We have the not protected, let's have public void does something. Then we can, of course, override this method. We can override the method, and so in this case we can print something different, like teaching chemistry. Chemistry, the same is about math teacher. Teaching math. Right, again, we can, let's assume we want to use the variable teacher, and the variable with the type teacher. Teacher. We have again three options we can create directly. Type teacher. Then teacher does. Teacher is teaching, then Here we can pass, can do the upcasting here, call the same method, and we can create instance of chemistry teacher, and in this case the implementation will be different than the one defined for the class teacher, for the type meant for teacher. Alright, and that's for the upcasting. We already discussed it today. I think it should be pretty clear for you. And yeah, in this case we can also do the downcasting, since we know that the teacher is not teacher. We can have another variable typed as math teacher. Here we can cast teacher to math teacher. Same way it will work if we try to cast it here. It will raise the exception. Because we cannot cast chemistry teacher to math teacher in this case. And that's why there's the exception, which can be called this way. We use try catch. Then we catch the exception. We can just check it from here. So this is the exception class cast exception. Then out print that casting is not possible. Casting is not possible. Maybe we can write it even this way. Casting from teacher get class to. So yeah, here we already know to math teacher is not possible. In this case we won't have this error. We'll just have the text from the code. Yeah, we also can have get simple name. And we'll see that casting from chemistry teacher to math teacher is not possible. That's kind of the way we can deal with these casting exceptions. Right. That's kind of example. Also, again, we can use the operator instance of to check to which class the object belongs to. So again, you can put the switch statement, for example. Let's not use the switch statement, just if statement. If teacher is instance of math
class teacher. Okay. So again, system out. And then again, else if teachers instance of chemistry teacher, then teacher is chemistry teacher. Yes. And then yeah, based on the result returned with the operator instance of, we will actually have, we can understand which instance the teacher belongs to, or just any object which is on one side of this operator. Let me check if I have something more specific to show you. I think for this topic I think we already had lots of examples. Just yeah, in case you have any questions about these topics, you are welcome to ask. I think we covered pretty well all of them. I hope I covered all the details, all the exceptions, all the usual things which happen with these with all these topics we had. I will share the presentation with you as well, and I also put the code to Bitbucket, push the code, and yes, don't forget that you have home task to be done today. So again, yeah, if you have any questions, please ask me. I will be available next 1.5 hours to answer. I already have some questions, so I will focus on answering to them. So please ask me the questions if you have. So all the home tasks are done for today. Right then, for today's session, I think that's it. Again, please ask me the questions, and let's meet on Monday. Thank you for your attention. Have a nice weekend.